Okay, welcome back. This is our second official lesson on radical expressions. And remember that radical expressions refer to the division of exponents. So we start by looking at our laws of exponents. Okay, laws of exponents, remember. Laws of exponents refer to the operation multiplication. So these are multiplication rules. We are counting the number of times in which we multiply. So we're starting with x squared multiplied by x to the third. When the bases match, what do we do with the exponents? We add. So we get x to the fifth. 2 plus 3 gives 5. Here we have x to the fifth divided by x squared. So when the bases match, x matches x, and we're dividing, we subtract the exponents. 5 minus 2 gives x to the third. And then we have x squared to the third power. When we have power of power, what do we do with the exponents? We multiply. We get x to the sixth. So you see addition, subtraction, multiplication of exponents. What is missing? What is missing? That was the division of exponents. Okay, so division of exponents, fancy division. This is a fancy division symbol, and this means division of the exponent. We're looking at x to the 10th power, the square root of x to the 10th. Remember, what is this little number if it's unwritten, or our index is 2? So we're looking here at x to the 10 divided by 2. 10 divided by 2 gives what? 5. And if you write x to the 5th, this is wrong. Because remember, when we have even 10 divided by an even index of 2, even divided by even divided by even, results in an odd value on the variable, we end up with absolute value. So this is actually absolute value of x to the 5th, reminding you, when we have even divided by even, results in an odd, we have absolute value. So even exponent divided by an even index results in an odd exponent is absolute value. And reminding you, we're looking at this symbol underneath is called the radicand. And this number out here is called the index. So we're looking again at square root, cubed root, fourth root. Index is 4, index is 3, index is an unwritten 2. Now, also foundations of radicals, really quickly reviewing. 2 times 2 is 4. Negative 2 times negative 2 is 4. So if I ask you what is the square root of 4, this asks the question, what number multiplies by itself to give 4? Can we argue that this is positive or negative 2? Yes, we can argue that this is plus or minus 2. The problem is, if we define the square root of 4 to be plus or minus 2, then this is not a function and does not have application. So the Society of Mathematicians has gotten together and decided to ignore which case. This is not plus or minus 2. Which case is chosen to be ignored? The negative case is chosen to be ignored, and the square root of 4 is just positive 2 to ensure what? The reason they did this was to ensure that square root is a function. Remember that we can only have one output for any input. Okay, so the input was 4, and the output was just 2, not 2 or negative 2. So if we put in 4, how many answers do we get? We just get one answer. Remember, one output or one answer results in what? A function. And if this is a function, it has application out there. So, square root of 4 is just what? Just 2. Now, this leads us to the result that the square root of a positive number can be arguably positive or negative. However, which case has the Society of Mathematicians chosen to ignore? They've chosen to ignore the negative case and just say that the output of the square root, if the radicand is positive, the output is just positive. And because of this, we end up with absolute value issues. Remember that absolute value will guarantee that our output is what? Guarantee that our output is positive. I still haven't explained this yet, so in the next video, I'm going to explain what does this absolute value mean, or where does this come from. You're going to hopefully try to wrap your mind around this. So to ensure that the output is positive, because we're ignoring the negative output case. Now, out in left field for a moment, square root of negative 4 asks the question, what number multiplies by itself to give negative 4? Well, 2 times 2 is positive 4. Negative 2 times negative 2 is positive 4. Can we find a number that multiplies by itself to give negative 4? I'm asking this in the real number system. Is there a number in the real numbers that make sense to us? Is there a number that makes sense to us that multiplies by itself to give -4? No. So for right now, we're going to say that this is non-real. We are going to learn about this soon, and this is going to exist only in our imaginations. So for right now, the square root of a negative number, is what? Non-real. However, if I say the cubed root of 8 or the cubed root of -8, if that index is an odd number, remember that 2 times 2 times 2 is positive 8. -2 times -2 times -2 is negative 8. So if I ask what number multiplies by itself 3 times to give 8, you say just positive 2. And what number multiplies by itself 3 times to give -8? That is the number -2. So does the cubed root have exactly one output for a positive input? Yes. Does the cubed root have exactly one output for a negative input? Yes. So one output. This is a function. We have no problems here. Remember, function has what? Function just has one output for any given input. So cubed root of a positive value is what? Positive. And the cubed root of a negative value is negative. Okay, so these are the 4 cases you have to have on paper. And what is our problem case? Our problem case is the square root. When the index is an even 2, we have problems. And the problems that exist, we have to use absolute value to guarantee that our answers are only positive, not negative. Now, again, this will be understood in the next video. Now, so today's lesson, we're just going to move quickly through the problems. I'm assuming that you understand the concept of taking out groups today, so I'm not going to really explain the concept of groups. If you're struggling with taking out groups on this video, you might have to go back and watch the previous video on explaining the concept of groups. Now, we're going to start with some properties of roots, or properties of radicals. So you have to understand the properties first. The first question is, can we multiply radicals together? So can I say the square root of 2 multiplied by the square root of 3? Can we multiply the radicands together? What's underneath the root is called the radicand. So I'm asking you, can we multiply the radicand 2 by the radicand 3 and get the radicand 6? Yes. The square root of 2 multiplied by the square root of 3 is 6. Yes, this is true. However, can we add the radicands? Root of 2 plus the root of 3, can we add them and get the root of 5? Absolutely not. You cannot add the radicand 2 and the radicand 3 and get the square root of 5. This is what? This is wrong. Now, so we're going to establish some properties. Properties are, let me say, maybe do this. So we're going to say that the square root of x multiplied by the square root of y, can we multiply the radicands together? Yes. The square root of x times the square root of y is the square root of xy. Remember, what operation refers to radicals? What operation are we studying? We are studying operation of what? Multiplication. So radical properties apply to what operation? Multiplication. So properties of radicals refer to multiplication. So this is true. However, if I write root of x plus the root of y, is this equal to the root of x plus y? Can we add the radicands together? Absolutely not. This is not true. Let me show you why. So if I write the root of 9, let's say root of 4, multiplied by the root of 9, question, can we multiply the radicands together? Yes. 4 times 9 is what? 36. So we get the root of 36. Now, what is the square root of 4? Well, if we look at this, the square root of 4 is 2, the square root of 9 is 3, and the square root of 36 is 6. Is 2 times 3 equal to 6? Yes. So you see that we can multiply radicands together. However, what if I write the root of 4 plus the root of 9? Can we add the radicand 4 to the radicand 9 and get the root of 13? Is it true that we can add the radicands? No, this is completely false. Let me show you why. The root of 4 is 2. The root of 9 is 3. And what is 2 plus 3? 2 plus 3 is 5. And is 5 equal to the square root of 13? No. 5 is equal to the square root of 25. So we see that all of this is completely false. Well, not the 2 plus 3 is 5, but the first part, The first part is false. Okay, so we cannot add the radicands together. 4 plus 9, 13, no. So again, can we multiply radicands? Can we say the root of x times the root of y is the root of x times y? Yes. Can we say that the root of x plus the root of y is equal to the root of x plus y? No. So this leads us into the first example. So the first example today, what are we doing with radical expressions? We are simplifying. And what does simplify mean? Simplify means to what? Add, subtract, multiply, and what? Divide. And we are going to start with multiplication. Okay, so multiplication of radicals. Let's look at on page 443. Page 443, number 5. So 443, number 5, we're looking at 5 root 2x multiplied by 3 root 8x. So the question is, and today you're going to see some weird stuff happening with respect to the absolute value that we talked about in the last video. So first we're going to multiply. Question, can we multiply the radicand 2x by the radicand 8x? Yes. What is the root of 2 multiplied by the root of 3? Can we multiply the radicands together? Yes, we end up with the root of 6. So yes, it is possible to multiply radicands together. So what I tell students is this. Multiply your numbers. So to start this problem, we're going to take the 5 times the 3 and get what? 15. Now multiply your radicands together. Under the operation multiplication, this works. We can do 2x times 8x and get the root of what? 2 times 8 is 16. X times x, we are adding the exponents. X times x is x squared. And now, what are we taking out? We're taking out groups of 2. Remember our unwritten index. If the index is unwritten, it is a 2, and we're taking out pairs. So we're going to take our 16 and break it down. Remember, we're getting it down to numbers 2, 3, 5, or 7, which are considered to be what's called prime numbers, numbers that cannot be broken down anymore. So 16 is what? 2 times 8. 8 is 2 times 4. 4 is 2 times 2. How many 2's multiply to give 16? Hopefully you say there are 4. So we're going to say that this is equal to 15 square root of 2 to the 4th x squared. Now, taking out your groups, how many pairs are there in 4? We have a total of 4 2's. Okay, how many pairs are there? There are 2 pairs. So each pair comes out. One more time, each pair comes out, becomes a 2. And what do we do with these 2 2's? We multiply them together. 2 times 2 is 4. Then we multiply by the 15 that's already out there. 4 times 15 gives 60. Now let me do this one more time much more quickly. Faster is to do this. So we say 15 root of 2 to the 4th x squared. We are dividing exponents. So instead of taking out groups, it's faster to think divide. Take the exponent 4 and divide by the index 2. What is 4 divided by 2? That's 2. So our new exponent is 2. This comes out and becomes what? 2 squared. Okay, so 4 divided by the index 2 gave a new exponent of 2. And so we end up with 2 squared. 2 squared is 4. And 4 times 15, we multiply these together. 4 times 15 is 60. And now, question, can we take a pair of x's out? Yes. How many pairs? Well, it's faster to divide. 2 divided by 2 gives 1. So we get x to the first power. We don't have to write the 1. And now the question is this the correct answer? Did we have even divided by even? Okay, so we have an even exponent divided by an even index. So we had 2 divided by 2 resulted in what? An odd number 1. So did we have even divided by even giving odd? Yes. However, although I said even divided by even gives odd results in absolute value, there is no absolute value on this problem. Uh-oh. So what I want you guys to do is today create questions. So why? Why even divided by even gives an odd 1? Notice, 2 divided by 2 gives an odd. So even divided by even gives odd. I said this is absolute value, so why are we not putting absolute value around the x here? Okay, so we need to answer questions today. Here, well, I won't answer these questions really till the next video, but I will give you some questions to be thinking about. Watch this. We understand that we can multiply radicands together. Okay, so what if I write this? If I write the root of x squared, okay, what is even divided by even? Okay, 2 divided by 2 gives 1. We get x to the 2 divided by 2, so even divided by even gives odd. This is x to the first power. We end up with what? Absolute value of x. Now, what if I write this? Root of x multiplied by root of x. This is weird. Okay, so we have what? Root of x times root of x. Can we multiply the radicands together? Yes. We get the root of x squared. And if we say even divided by even gives odd here, does not matter. This is just x. The square root of x squared, we take out a pair of x's, we end up with x. No absolute value on this. So what is the difference between these two cases? So one more time, very quickly, you can just write this in your notes as something to be thinking about. Okay, so we're looking at the root of x squared is the absolute value of x, but the root of x times the root of x, which is equal to the root of x squared, is just x. No absolute value. So how does that make sense? The first time I saw this, I wish someone would have told me this in high school, because the first time I saw this was in college. And I looked at my professor and I said, you've got to be crazy. These are the same thing. And he looked at me and he said, no, this is not the same thing. Okay, so if you have to learn what is the difference between these two. The root of x squared is the absolute value of x, and here we have the root of x squared as x. I wish someone would have told me this in high school. So you guys are going to learn in the next video. I'm going to do a short snippet on absolute value, and you guys will see the difference here. Notice, what did we have here? We had root of x multiplied by what? Root of x. Root of x times root of x. We don't have absolute value in this case, so our answer is just 60x. Now, the next problem, if you thought this was weird, the next problem is even worse. Okay, so look at this next problem, number 7. I just want you guys to have questions in this video. What is going on with this whole absolute value thing? What is this? Even divided by even gives odd. This one will blow your mind. So this is when I really started to say, I give up. Okay, so it took me a long time. I had to dig this information out. And finally, it occurred. What is actually going on here? And I was able to figure this information out, and I'm going to share this with you guys. Looking at number 8, this is interesting. Number 8, it takes time, guys. This is not something that you just look at the first time and go, oh, I get it. So we're looking at the fourth root of 3 x to the third y squared multiplied. I will give you some hints to be thinking about. Fourth root of 27 xy squared. I do like the textbook for this reason. It does address the absolute value issue. At least it does give the right answers in the back of the book. So in this case, the question is, what operation is between the radicals? What operation? Multiplication. What did I say? We are simplifying. We are multiplying radicals first. So we are multiplying. Question, can we multiply the radicands together? Yes. Remember that the root of x times the root of y is the root of xy, or the root of 2 times the root of 3 is the root of 6. We can multiply the radicands together, so we end up here with the fourth root of one radical. So 3 times 27 is 81. We're multiplying. 3x's times one more x. We're x cubed times x. We're adding the exponents. This is x to the fourth. And here we have y squared times y squared. 2 plus 2 gives what? 4. So we end up with y to the fourth. And we're taking out groups of what? Groups of 4. So we're going to start by taking the 81 and breaking it down. So let's take 81, break it down. 81 is what? 9 times 9. Now break the 9s down. What are the 9s? 3 times 3, 3 times 3. How many 3's multiply to give 81? Hopefully you say 4. So we're looking at the fourth root of 3 to the fourth, x to the fourth, y to the fourth. And if you think in this in terms of taking out groups of what? Groups of 4. If we take out a group of 4 3's, remember every group comes out becomes 1 on the outside. So a group of 4 3's comes out becomes just 1 3. A group of 4 x's comes out becomes just 1x. A group of 4 y's comes out becomes just what? 1y. And is this the correct answer? No. What did we have here? We had even divided by even. Let me just write it like this. So 4 divided by 4, x to the what? 4 divided by 4, y to the what? 4 divided by 4. We end up with what? Even divided by even gives what? Odd. 4 divided by 4 gives 1. X to the first, y to the first. So we have what? Even divided by even gives odd. Even divided by even gives odd. And even divided by even gives odd. So we have a possibility of absolute value case. Well, really what I said here, every one of these should be absolute value, except, do we need absolute value around the 3? No. Absolute value is to guarantee that an output is what? Absolute value is to guarantee that an output is positive. Remember I said that the rules that apply to square root also apply to what? Fourth root. Or I should say this. This rule of positive output applies when the index is even. Okay, so when we have an even index, not just square root, but any root with an even index. So 4 divided by 4 gives 1. 4 divided by 4 gives 1. 4 divided by 4 gives 1. We have even divided by even giving odd. However, do we need absolute value around the number? No. We already know that the 3 is positive, so there's no need to guarantee that the 3 is positive. Remember that absolute value goes only around the variables. Now this one will really confuse. Okay, so look at this. We have even divided by even gives odd, even divided by even gives odd. Do we have absolute value around both? No. So in this case we have absolute value around the y, but not absolute value around the x. Now does that make sense? No. The first time I saw this again, I was so confused. Wait a minute. You said even divided by even. No, there's more that goes into this than just memorizing this. Okay, so we have to look. Let me give you a clue. What did I say? Even divided by even gives odd. Look at your original exponents of x. What were the original exponents of x? Were they even or odd? Hopefully you noticed that the original exponents were what? They were odd. Okay, now the original exponents of y were what? The original exponents of y were what? Even. So we go back to the original problem. Okay, the original problem written was even exponent for y, even exponent for y. This led to possibilities of absolute value. So when do you determine absolute value? You determine the absolute value at the beginning, the initial problem that's written. Notice, can we ever have absolute value around the x? No, because we started with odd and even. However, can we have absolute value around the y? Yes, because we started with what? Even. Okay? Can we ever have absolute value around the x? No, because we started with odd, even. Can we ever have absolute value around y? Yes, because we started with what? Even. That's just a small clue. Okay, so that's something to be thinking about. All right, but this, I think, is even more interesting. This right here, what I wrote on the board to begin with. Now, so the key here, what I need you guys to understand today, not the absolute value, I need you guys to understand what do we do when we multiply radicals? Can we multiply the radicand themselves together? Yes, so we can combine the radicals as one radical. Now, we're going to switch from multiplication to what? Addition and subtraction. The rules are completely different. Okay, so now we're going to be looking at addition. Again, addition makes our lives difficult. So, looking up top, we say the root of 2 multiplied by the root of 3. Can we multiply the 2 and the 3 and get 6? Yes. However, what is the root of 2 plus the root of 3? Can we add the radicands together? No. Okay, so we say that this is not equal to the root of 5. There's nothing we can do with this. We cannot add the 2 and the 3, so we say that this is already simplified. There's nothing you can do. Remember that simplify means to add, subtract, multiply, and divide. So you cannot do this anymore. There is nothing you can do with these two. They do not match. Remember, when you add, something must match, and what matches doesn't change. Now, looking at let me say this before we go on. However, what if I say this? The root of 3 plus the root of 3. Remember, when we add, something must match, and what matches doesn't change. Now, you cannot add the 3 and the 3 and get 6. However, when we add, something must match, and what matches doesn't change. So does the root 3 match the root 3? Yes. We can add these together, not as radicand plus radicand, but rather what matches doesn't change. We have a root 3 that does not change. We add what's in front. 1 root 3 plus 1 root 3. 1 plus 1 is what? 2 root 3. So if I say just like this, x plus x is 2x, we can say that root 3 plus root 3 is what? 2 root 3. So even though we cannot add the 3 and the 3, if they match, we can add what's in front. So 1 plus 1 gives 2 root 3. Now, there's a quick example. So we're looking at number 9. 5 root 32 plus the root of 27 plus 2 root 75. Okay, so we notice first off, what operation is between our radicals? What operation do we have between our radicals? We have addition. So the question is, can we add the 32 and the 27 and get 59? Can we add the radicand 32 to the radicand 27 and get 59? No. Can we add 27 to 75 and get 102? Absolutely not. So we cannot add the radicands together. So what do we do here instead? To simplify this, we're going to take out groups and see if we can find something that matches. Because if we add root 3 plus root 3, if something matches, we can add the roots together. We end up with what? 2 root 3. What matches will not change. So we can add things if something matches. We can combine them as 1. Now, so we're going to first start by taking out groups. Take the 32 and break it down. So this is just 3 factoring problems. You're going to break down the 32, break down the 27, and break down the 75. Well, let me do it in order. So let's do 32 here. So 32 is what? 2 times 16, which is 2 times 8, which is 2 times 4, and 4 is 2 times 2. How many 2's multiply to give 32? Hopefully you say there's 5 of them. So we're going to write the root of not 32, we're going to write 2 to the 5th power. Plus, now break down the 27. 27 is 3 times 9, which is 3 times 3. How many 3's multiply to give 27? Hopefully you say 3. You should memorize this one. This one's very common. This is 3 to the 3rd. And now break down 75. I always tell students first, think in terms of dollars. 75 cents is how many quarters? Well, that's 3 quarters. So we can say 3 times 25 cents. Now break the 25 down as what? 5 times 5. How many 3's multiply to give 75? Hopefully you say 1. And how many 5's? 2. So we're going to write this as plus, don't forget your 2, 2 root. How many 3's? 1 3. And 2 5's. So 5 squared. All right, now, broke down the numbers. We're now going to take out what? Groups of, what are we taking out here? Groups of 3 or groups of 2? Hopefully you say groups of 2 because what is our index? Our index is an unwritten 2. Remember that square root, what is the index of square root? Index of square root is a 2. So we're taking out pairs. How many pairs can we take out of 5 2's? Okay, so again, showing you 5 2's. How many pairs can we take out? There's a pair. There's a pair. Every pair comes out, becomes a 2. So this pair of 2's comes out, becomes a 2. This pair of 2's comes out, becomes what? A 2. And we multiply these together. So 2 times 2 is what? 4. Now multiply by the 5 that's already out there. That's what? 4 times 5 is 20. Another way to think of this is what is the next exponent below 5? Remember, we're dividing. This symbol means divide by 2 on the exponent. What's the next exponent smaller than 5 that is divisible by 2? You say 4. Okay, what is 4 divided by 2? 4 divided by 2 is 2. And so since 4 divided by 2 is 2, we end up with 2 squared on the outside. The result of 4 divided by 2 is this new exponent 2. So we get 2 squared, which is 4. 4 times 5 is 20. And what's left? We took out a total of 4 2's. We took out a total of 4 2's. How many 2's are left? There's 1 2 left. Now, we have 3 3's. Can we take a pair of 3's? Yes. Okay, so take a pair of 3's out. We have how many 3's on the outside? Well, we took out 1 pair, so there's 1 3. What's left underneath? We had 3 3's. We took out a pair of 3's. So 1 3 on the outside. What's left? There's a 3 left underneath. Now, here on the third root, can we take a pair of 3's? No, because we only have 1 3. However, can we take a pair of 5's? Yes, there's a pair of 5's here. We take a pair of 5's out. What does it become? It becomes a 5. We take the 5, and do we add it to the 2? No, we multiply it. So 5 times 2 gives what? 10. And what's left under the root? We have a 3. So 10 root 3. And now, are we done taking out our groups? Yes. What are we doing? We are adding. Remember, when we add, something must match, and what matches doesn't change. So we look for things that match. Does something match our root 2? No. So we look for matching radicals. No, nothing matches root 2. So I want you to write 20 root 2 and cross it out. Now, does something match our root 3? Yes. And when we add, what matches doesn't change. So the root 3 will not change. Add what's in front. 3 plus 10 is what? 13. So we end up with 13 root 3. For instance, if I asked you here, you're looking at 3 root 3. 3 root 3 plus 10 root 3 is 13 root 3. It's the same question as if I ask you what is 3x plus 10x. When you add, what matches doesn't change. We end up with what? 13x. So if I say 3 root 3 plus 10 root 3, we look at this as 3x plus 10x is 13x. Or what matches doesn't change. So we end up with 13 root 3. And this is your final answer. This is fully simplified because we cannot add anymore. Can we add the root 2 to the root 3? Absolutely not. Remember that you cannot add your radicands together. Now, so next question. one more like this. Let's do one more example of addition. How about problem number, let's see, problem number 30. So 3 root 90, let's see, plus 4 root 20, plus root of 162. Okay, so here we're taking out what? Taking out groups of 2. We have to start by breaking down our numbers. So take 90, break it down. What is 90? 9 times 10. Break these down. 9 is 3 times 3. 10 is what? 2 times 5. So we rewrite this as 3 root of how many 3's? Well, we have 2 3's, so 3 squared. We have a 2, and we have a 5. So 3 squared times 2 times 5 plus 4 root. Breaking down 20. 20 is 2 times 10. Which is 2 times 5. We have 2 2's, so 2 squared times a 5, plus the root of 162. Take the 162, break it down. This is 2 times 81. 81 is what? 9 times 9, or 3 times 3, 3 times 3. How many 3's multiply to give 81? There's 4. So we have 3 to the 4th times 2. Now, taking out groups of 2 because this is square root. Our index is 2. Taking out pairs, we look at first, can we take a pair of 3's? Yes. So we take a pair of 3's out. One pair becomes a 3. And what do we do with the 3 and the 3 that's already out there? We multiply them. We do not add them. 3 times 3 is what? 9. And what's left under the root? Well, we cannot take a pair of 2's and we cannot take a pair of 5's because we only have one of each. We multiply these back together. 2 times 5 is a 10. Now, can we take a pair of 2's on the next? Yes. One pair of 2's comes out, becomes a 2. Can we multiply the 2 times the 4? Yes. We do not add them, we multiply. 2 times 4 is what? 8. And what's left under the root? We have an extra 5, so we put a 5. Now, 3 to the 4th, we're taking out pairs. It's faster to divide. What is 4 divided by 2? 4 divided by 2 is 2, so we get a new exponent of 3 squared. So our new exponent is a 2. Because 4 divided by 2 gives a 2, or the concept of taking out 2 groups. 3 squared is what? 9. And what's left under the root? Well, we took out all of our 3's, so we have an extra 2. Now the question is, are we done taking out groups? Yes. Now I'm asking, we're adding something must match. Does something match the root 10? No. Does something match root 5? No. Does something match root 2? No. So since nothing matches, there is nothing that you can add together. You are done. This problem is completely simplified. Okay? So we are simplified at this point. Remember, you can only add when something matches. So again, when you add, something must match. What matches doesn't change. All right, now, last problem. We're going to do everything. So we're going to combine addition, subtraction, and multiplication. Now my question is, what happens when multiplication meets addition? When multiplication meets addition, what property applies? Hopefully you say distributive property applies. So what happens when multiplication meets addition? We're going to look at first 3 plus the square root of 5 multiplied by 4 minus 2 square root of 5. So here you see what? Operation of multiplication meeting the operation of addition. Now we learned this with respect to polynomials. What happens when multiplication meets addition? We distribute. So we take the binomial and distribute. But I showed you guys a trick. When multiplication meets addition, what is the trick that we can use? We can FOIL. So we're going to take the first term. The trick is to take the first term, multiply by what? Multiply by both. And then we're going to take our second term and multiply by both. So let's start with the first. So we're going to do the first term 3. Let me erase these two arcs. Let's take the first term 3 and multiply by both. 3 times 4 is what? 12. And now, do 3 times the 2 root 5. So I tell students this. Do numbers times numbers, radicands times radicands. So 3 is a number. Is 3 underneath a root? No. Is 2 underneath a root? No. So you're going to multiply the 3 and the 2 together. Is the 5 underneath the root? Yes. So we do not multiply the 5 by the 3. Okay, so we're just going to do 3 times the 2 and get what? Be careful. Positive times negative. 3 times negative 2 is what? Negative 6. And we glue the root 5 on the end. So just glue it together. So 3 times 2 is 6 root 5. Think of this if I ask you, what is 3 times 2x? What is 3 times 2x? We get 6x. Okay, so what is 3 times 2 root 5? Think of 2 root 5 as 2x. You would get what? 6x. So I want you to think of this root 5 as an x. So 3 times 2 gives 6, and we glue the root 5 to the end. Now, take the second term and multiply by both. So the question is, what is root 5 times 4? What is root 5 times 4? Glue it together. The 5 is underneath the radical, the 4 is not. So we're just going to glue it together, put the number that's not underneath the radical first. So put your 4 first, and then put your root 5 on the end. Now, we have to do the root 5 times the 2 root 5. Before we do this, let's start this little exercise. And I tell students this many times. Can you get this today? Okay, so try to digest this now. The root of 2 times the root of 2 is the root of what? The root of 4. Can we multiply the radicands together? Yes. Root of 2 times root of 2 is root of 4, which is 2. Okay, what is the square root of 3 times the square root of 3? Well, the square root of 3 times the square root of 3 is the square root of 9, which is just 3. The square root of 5 times the square root of 5 is what? The square root of 25, which is, what is the square root of 25? 5. Do you see a pattern here? Okay, so what is root 7 times root 7? This is 7. What is the root of 9 times the root of 9? This is 9. What is the root of x times the root of x? This is what? X. Written over here. Okay, so again, one more time. So we use a pattern here. This is whenever you multiply two roots, the root cancels out. Root 2 times root 2 is what? 2. Root 3 times root 3 is what? 3. Root 5 times root 5 is what? 5. Why? Because the root of 5 times the root of 5 is the root of 5 squared. We take a pair of 5s out, we just get what? 5. So what is this? We're looking at, students do this all the time, but it makes more work. But they do the root of 5 times the root of 5. Do we multiply the radicands together? Yes. They end up with negative 2 stays out front. They do root 5 times root 5 and get the root of 25. The problem is, they forget to take the root and simplify it. So rather, think in this terms. What is root of 5 times root of 5? Or I should say, what is the root of 25? The root of 25 is just 5. So you can take the 5 and multiply by what? Take the 5, multiply by the 2, and get 10. So this is minus 10. So you do not have to write 2 root 25. You can just write what? Minus 10. Again, what is the root of 5 times the root of 5? The root of 5 times the root of 5 is 5. So if you think, what is root of 5 times root of 5? That's 5. Now take the 5 and multiply by the 2. What do you end up with? You end up with a 10. Now, we combine under addition. We're done multiplying. When we multiply, things do not have to match. We can multiply radicands together. However, now we're adding, so things have to match. We add the numbers first. 12 subtract 10 gives what? A 2. Cross the 12 and the negative 10 out. Now, do we have something that matches here? Yes. Root 5 matches root 5. What matches won't change because we're adding. Add what's in front. Negative 6 plus 4 gives what? Negative 2 root 5, and we are done. So this is the fully simplified answer. Now, one more question. Let's look at number, how about number 38 in the book. Well, I guess we can do number 38. Number 38 is 8 root 5. Well, no, let's do number 12. Number 12. Okay, so number 12 is what? 8 root 3 minus 2 root 2 multiplied by 8 root 3 plus 2 root 2. Okay, so here we have what? Multiplication. Multiplication meeting addition. When multiplication meets addition, what property applies? Distributive property. Now, we learned a trick when we use distributive property with respect to binomial. And what? Binomial. You see two terms separated by addition. This is binomial. Two terms separated by addition is binomial. So binomial times binomial, we FOIL. Take the first term, multiply by both. Remember, number times number, radical times radical. So here we do what? 8 times 8 gives 64. And what is root 3 times root 3? Again, root 5 times root 5 is 5. Root 2 times root 2 is 2. Root 3 times root 3 is what? 3. So we're looking at root 3 times root 3 gives what? Just 3. So we have 64 times 3. 64 times 3 is 192. So the first is 192. Now take the 8 root 3 and multiply by the 2 root 2. Number times number, radicand times radicand. So 8 times 2 gives what? 16. And now the root 3 times the root 2. Can we multiply the radicands together? Yes. Okay, so root 3 times root 2 gives root 6. Now, take the second term and multiply by both. So we're going to start with the 2 root 2 times the 8 root 3. Negative times positive is negative. Negative 2 times 8 is negative 16. Root 2 times root 3 is what? Root 6. And now take the negative 2 root 2 and multiply by the positive 2 root 2's. Okay, so negative 2 times 2 is negative 4. And what is root 2 times root 2? It's written here. Root 2 times root 2 is just 2. Okay, so we have root 2 times root 2 is a 2. 4 times 2 gives what? 8. So we have on the end minus 8. Oh, minus 8. And now we combine. Start with your numbers. 192 minus 8 is 184. Cross your numbers out. And now 16 root 6 minus 16 root 6. Do the radicals match? Yes. So we add what's in front. What is 16 minus 16? Okay, remember the root 6 does not change. What is 16 minus 16? We get what? 0. So we end up with what? Plus 0 root 6. And anytime you have a 0, this just cancels out. We don't write it. So we don't actually write the 0 root 6. The final answer is 184. And that concludes this video. Good luck on your homework, guys.